We have discussed about the spatial referencing. Spatial referencing involves geographic coordinate system, rectangular or projected coordinate system, and non-coordinate system. Okay. So in geographic coordinate system, latitude, longitude, exact coordinate system, or rectangular coordinate system, or a planar coordinate system, the example will be UTM or UK Ordnance Survey National Grid. For the non-coordinate system, the pin code, the postal codes are the best example of non-coordinate system. After that, we have seen the different sources of spatial data. Map. Apart from map, there can be land surveying, census and survey data, aerial photographs, satellite images, and GPS. Thereafter, we have seen the different types of attribute data. There are broadly 4 classification of the attribute data. Okay, so this is nominal data and ordinal data, interval data, and ratio data. This is how we have learned the classification. Open your notebook. All of you open your notebook. Yes. So when we talk about the data in GIS, the data can be of 2 types, isn't it? It can be spatial data and it can be non-spatial data. What will be the other name of non-spatial data?
Attribute data.
Attribute data.
It will be attribute data. Now, if we see the attribute data can be classified as nominal, ordinal, interval, and ratio. Okay. And when we talk about the spatial data, the another side, what can be the 2 types?
Vector and raster.
Yes. There will be raster data and vector data. So this is how we will put the classification, the data. All those students who do not remember this thing, write it down in your copy. The data in GIS, it will have 2 components, spatial and non-spatial. Spatial means location. Okay. So the spatial data will carry location. The non-spatial data will be the attribute data. It will give the characteristics. The non-spatial data can be categorized in 4 different ways: nominal data, ordinal data, interval data, and ratio data. The nominal data, when you cannot perform any sort of arithmetic operation, then it will be the nominal data. The proper nouns will come under the nominal data. Ordinal, that will give you some order, some ranking. Interval, you can perform the arithmetic operation of addition, subtraction, but it will not have the absolute 0. In case of ratio data, you can perform all sort of arithmetic operation and it has an absolute 0 position. So this part we have already done. Now we are coming to this particular part, spatial data. In spatial data, there will be 2 types, raster and vector. We will cover in this turn about the raster data and vector data. So this particular section involves the spatial data modeling. Okay. So when we talk about the spatial data modeling, what does it mean? Like suppose if you want to model anything, suppose I want to create, say, like give you, I don't think so you people have visited, I'm in an IT campus. So, okay, just try to model your BTech institute. Okay, Suppose if you want to do the modeling of a BTech institute, how will you model that one? Just try to make a map of your campus in a copy. Hopefully all of you have made the sketch or make some map of your BTech campus. While drawing such type of map or while selecting or while portraying all these things, what you have found that it is not possible to show everything what is present in your campus, isn't it? That I don't think so. You people have made all the roads, all the trees, all the power lines, all the water coolers, all the academic buildings, lecture hall campus, administrative wings. I don't think so. You people have drawn all these things on your map. Okay? So when you are making such type of map, what will happen? You will select those entities which were as a student that in which you are interested. Like you may like to have some, say, all the lecture halls location, all the water coolers, library, canteen, all these locations, isn't it? But there are so many other things that would be present in your campus and that you have not shown on your map. When we are doing the spatial data modeling, this is what the problem is. That somebody is not on mute, please mute yourself. So when we have to take anything, when we have to do the spatial modeling, the first thing is we have to identify the features that are present in the real world that we are going to take. And it is not possible to take each and every spatial feature. We have to select them, and how that selection that take place, or how the things will get eliminated from the list. The answer is it depends upon your project. It depends upon the purpose of data collection or the modeling. Okay, so first thing is which entity, identifying of entities that we are going to take. Once such entities has been taken up, okay, the next step is when you have to put it in GIS, you have to represent in some sort of conceptual data model. Okay, so those students who have studied the database in the BTech, they must remember there are conceptual model and physical model. Okay, So conceptual model are the logical models in which actual storage is not done. It will give you the concept only. The actual storage inside the system will done through the physical data models, isn't it? So here also in GIS, same thing will happen. Once the entities are identified, the next step will be the conceptual model. There are two conceptual model, raster data model and vector data model. So there are two different ways in which that location, those spatial entities can be represented. And once this conceptual model is finalized, we have to decide the physical model in which the data will get stored inside the machine or the computer. Okay. So coming to the very first part, which is the entity definition. There is an example. Okay. This one is the example of Happy Valley. This example is taken from the book Ian Haywood. So from this particular example, you can see that there is a Happy Valley. And in the Happy Valley, there are so many things, like there will be hotels, there will be forest, there will be skiing lift, road network, elevation. There are so many data over there. And other than this, there are several other data also. But, you know, when they are making some model for the tourists, they are selecting those things in which the tourists will be interested. So once they have identified these things that they are going to take forest, skiing lift, hotel, road and elevation, the next thing that they need to decide is which type of spatial entity type that they will take. What are the different spatial entity types of spatial entities? Anyone? What are the three basic types of spatial entity?
Point, line, polygon.
Points, lines, and polygon.
Yes. So these three are the basic spatial entities: point, line, polygon. And for more advanced, line will be network. Okay. And from the area, it will be surface. Okay. So point, line, area, network, surface. These are the 5 different spatial entities, or there will be 3 basic entities: point, line, and area. Okay. So while doing the spatial entity modeling, or when we are trying to define the spatial entity, like suppose I will give you one of the example. Like first there is a forest. Okay. How will you model the forest? Like a point, like a line, or like a polygon?
Polygon. Polygon.
Polygon.
Polygon.
So first answer that I am getting is of polygon. Okay. If I open the Survey of India map,
Well, in case of reserve forest, we can mark with points.
yes. Somebody was saying anything?
In case of reserve forest, we can mark with single points, few single points.
Why? Why?
The forest may not be continuous due to deforestation.
Okay. So what will be the location of that point?
Anything we will mark with point or area, it will depend on scale of map.
No, you are, yes, that thing is correct. One thing is scale. Definitely it is a scale. And on the basis of scale, if we have a large scale, the entity will be represented by a polygon. At a small scale, the same entity could be represented by a point or by a line. Okay. Like we have seen the example of Mississippi River in generalization, if you remember. So there were different scale. 1 is to 25 million, 1 is to 5 million, 1 is to 250,000, 1 is to 50,000. So at 1 is to 1:20 million and 1:5 million at both the scales, Mississippi River and its tributaries were shown by a line. But at a larger scale, like 1:25, 250,000 and 1:50,000, the Mississippi River was shown by a polygon. So yes, one thing is scale. Second thing is, like we were discussing how the forest could be represented. As you can see on the screen, this one is the Survey of India topographical map. This one is showing some of the reserve forest, Amba Reserve Forest, Gad Chhapa Reserve Forest, okay, Dhurkuch West Reserve Forest, Dhurkuch East Reserve Forest. So many reserve forests are shown over here, and these are given by a polygon. Okay. Now suppose there is a lot of deforestation, or there is several trees that have fell, or there is some disease, and because of that trees have been fallen down. Can we represent such type of thing with the help of a polygon? When there is a change in the density of trees inside the forest, can this information be represented by the polygon?
Ma'am, by using
Sorry, continue the
polygons. Ma'am, by using different shadow color of polygons. Suppose there is a high density of forest, then that can be used by dark color, and by light density of forest that can be used by light shadows.
No. It is different thing. It is just for the representation purpose. Okay. So when we are storing it, we cannot represent it like this way. In that case, yes, you can add the attribute of number of trees. Okay. What you are telling that we can use different shades, and on the basis of the shade, we can tell for this purpose we will need one attribute of number of trees. In the laboratory session, we have learned how to add the attribute and populate the attribute table. Here also you can do this thing, that you can add another attribute of number of trees with them and show them with a different colors. Okay, but still you cannot show it, means you cannot show it accurately. There will be a certain range over there. You cannot show every polygon with a different color. One of the solution could be that trees will get represented by a point instead of polygon. Each point represent a tree or certain number of tree. We create dot density map. Later on, you will learn about the dot density map. Suppose one dot means 10 trees. Okay. So in this case, we can use multi-point. One of you have asked me that there are 4 different types: point, line, polygon, and multi-point. What is the meaning of multi-point? So this is how we will use the multi-point. Like for Amba Reserve Forest, we will use multi-point. So all the point will belong to one specific type. Okay. So one of the way of representing this information can be of point. Real world is very dynamic in nature. We may want to show that dynamicity in our data set. So on the basis of that, we can decide whether we will go for a point representation or we will go for a line representation. Like if we take the example of Happy Valley, in that case, the tourists do not need the exact information of number of trees. They just want to know where the forest is located. In that case, the polygon is okay. But suppose there is some person from ecology or some person who is working in the forest department and they have to maintain this record of number of forest. As you remember, the definition of the GIS says that it used to create the inventory of spatially distributed features. So in that case, they will use point to represent the forest. So nothing is wrong. There are different ways. It depends upon the application, it depends upon the use, how that data set will get used, who are the possible users of that one. On the basis of that, we can change polygon by a point. Then another thing is about the perception. Real world is dynamic, there is no doubt in it, but our perception is also dynamic. Once we are taking the thing as a tourist, another time we are taking all these things as an environmentalist. One time we are taking, suppose there is road, as a tourist we just need a line which shows us the major road on that city. But as a maintenance purpose, suppose I belong to civil maintenance department, in that case, I will need all the detail of road, all the dividers, zebra crossing, traffic signal, everything on the road. In that case, the same road will get shown by the polygon. So it depends upon our requirement also. Next thing is, right now on the screen, you have seen the reserve forest like a polygon. And the boundary of these reserve forests is very clearly shown on the map. Is it correct? Or is there anything wrong in this one? Is it correct to show the forest polygon by a very well-defined line, boundary by a well-defined line?
No, ma'am. Natural features
No,
have
ma'am.
fluctuating lines.
Yes. So answer is no. The natural features doesn't have a well-defined boundary. Right now on the screen, I have opened the sentinel image of the same area. Okay, this one is the sentinel image of the area, same area, and you can see this purple color patches on the screen. Okay, these purple color patches on the screen are the forest over here. It depends upon the band combination. It is not necessary that the vegetation will always appear like green color. It depends upon the band combination, in which particular band combination the data set is shown, and also it depends upon the software. So right now on the screen, this purple color is forest. Okay. You can see it if I overlay the map on this one. I am overlaying this map on the image, and here you can see this purple color region is the forest. And now on the sentinel image, satellite image, you will find that identification of the boundary is not simple. Okay, like I am zooming into it, you can see that there is a change in the shades. Okay, at the center it is quite dark purple, and as you move towards the edges, towards the boundary, the shade is coming towards the lighter tone. So this is what the problem with the natural features. The natural features boundary is not well defined. It has a very vague boundary. It has a fuzzy boundary. We cannot define them like a hard boundary. The man-made feature, like when I talk about the MNIT campus, the boundary of the MNIT campus is very well defined. There is a hard boundary, there is a boundary wall. If you go outside that boundary wall, you will be outside the MNIT campus. If you come inside that boundary wall, you will inside the MNIT campus. But when you see the natural feature, this is not the thing, because it will gradually decrease. Like in this example, there is a forest. The boundary of the forest will not be certain particular point. You will see when you move outside the forest, and if you reach towards the boundary, the density of forest will start decreasing. The number of trees will start decreasing. So there will be a gradual change. Okay, slowly and slowly you will find that the number of trees start to decrease, and then you will find there is few houses over there, and then after certain point you will find that there is not at all any tree, and there is only urban settlement around it. This is what the problem is when we try to model any of the natural feature, that the boundaries are not very well defined. Okay. I have given you the example of the forest. Another example, another example is this river. Okay. Again, you can see I'm just zooming in. This one is the river Ganga. Okay. If I open the map, there is a lot of displacement in the map. But here you can see that this one is the river Ganga, and this river Ganga again doesn't have a very well defined boundary. You can see the same vagueness over here. Okay. So this is what the problem is when we try to model the spatial entity. The very first step is the entity definition, and the problems are listed over here that I have just told you. There are a number of problems associated with simplifying the complexities of the real world into basic two-dimensional entity types. These include first, dynamic nature of the real world. The real world is not static. Forests grow and are felled. River flood and change their course. Cities expand and decline. The dynamic nature of the world poses two problems for the entity definition phase of a GIS project. The first is how to select the entity type that provides the most appropriate representation for the feature being modeled. Is it best to represent a forest as a collection of points or as an area? The second problem is how to represent changes over time. A forest originally represented as an area may decline as trees die or are felled until it is only a dispersed group of trees that are better represented using points. In addition, the change of the physical features themselves may remain static, but our perception of their geographic structure may differ according to our application area. For visitors to find their way around Happy Valley, a map of the road network with roads represented as a series of the interconnected line would be sufficient. However, for road maintenance engineers who must repair the surface after the winter season, it may be more appropriate to represent the road as areas or even as surfaces. Identification of discrete and continuous feature. The definition of entity type for real world is also hampered by the fact that many real world features simply do not fit into the category of entities available. An area of natural woodland does not have a clear boundary. Okay? We have just seen the example of forest. Okay? As there is normally a transition zone where trees are interspersed with vegetation from neighboring habitat type. In this case, if we wish to represent the woodland by an area entity, where do we place the boundary? The question is avoided if the data are captured from a paper map where boundary is clearly marked, as someone else will have made a decision about the location of woodland boundary. But is this the true boundary? Vegetation to an ecologist may be a continuous feature, whereas vegetation to a forester is better represented as a series of discrete entities. So we have just seen this thing, that when you are making the forest, suppose if you want to digitize the forest, if you take topographic map, there is no problem because the Survey of India has decided the boundary of forest. So you do not need to do anything. You will just throw the responsibility on a third party that, Survey of India has given me. I am not responsible if there is any mistake. Okay. But if you are digitizing the forest or if you are digitizing the river by yourself from the image, digitization can be done on a map as well as it can be done on the image also. Okay. You have done the digitization on the map, but you can perform the same thing on the image also. Like, means practically when we perform such type of thing, and if we have to do the digitization of some natural feature like river, okay, like forest, in that case, instead of going to the map, we go for the satellite images. Why? Because the satellite images provide you the latest data. The Survey of India will give you the map after certain time. Okay, like if I show you this thing, this map was surveyed in the year 1972 to 1974. Okay. If we try to digitize river from this data, it will be completely incorrect. Okay. Because there is a lot of change in the course of river and natural features. If I take more recent map, to copyright in the year 2012, so maybe the surveys performed somewhere in 2010 or 2011, 2010 or 2011. Again, this is at least 10 years old data. So if you try to digitize from the latest Survey of India topographic map, the data set will be at least 10 years old. In that case, the boundary of the natural features will not come correct. Therefore, you have to take the satellite images for that purpose. So when you are doing this thing, the onus lies on you where you are putting the boundary of such type of thing. So this is all about the entity modeling, and third point is the scale at which particular problem needs addressing. So these are the different problems when we try to model the complex real world situation in GIS. It starts with the first step of entity definition, and we have seen the problems associated with that one. Once the entity definition is done, the next step is we need to identify the data models. Okay. So data structure provides the information that the computer requires to reconstruct the spatial data model in digital form. Data structures can be classified according to whether they are used to structure, raster, or vector data. First one is the raster data model. The raster data is commonly associated with field conceptual model. Here, geographic space is represented by array of cell or pixels, which are arranged in rows and columns. Each pixel has a value that represents the information. The value can be in the form of integer, floating points, or alphanumeric. Second is vector data. Vector data model is closely linked with the discrete object view. In vector data model, geographical phenomena are represented in three different forms: point, line, and polygon. The shape of the entities is stored in two-dimensional XY coordinate. So basically, when we talk about the spatial data model, I come back to this one. There are two options in which we can store the spatial data, in the form of raster data, in the form of vector data. In some of the book you will find there is a third data model also. In some of the books you will find this one also. So the spin is triangulated irregular network. Okay, but in general, instead of considering 10, we have two data model, basic data model, raster data model and vector data model. When we talk about the first one, raster data model, as I have read in the PPT, in case of raster data model, the whole area is represented by cells or pixel. Like you can take the example of images. Okay, the images are the example of raster data model. Apart from the images, there are several other things like elevation data, land use, land cover data. Such type of data is represented in the raster data model. So basically, what will happen? The whole area will be divided into cell. There will be a gridded data, and with each and every cell, certain information will be associated. Another way of representing the same thing is vector data model. This one is the discrete data model. Like raster data model is used for something that is continuous in nature, where you will have a value at each and every place. In that case, you will go for a raster data model. But when the things are discrete, like suppose if there are schools, the schools are not present everywhere. If we take the example of hotels, they are not present everywhere. Hospital, they are not present everywhere. So these things are discrete. They are not continuous. They are not present at everywhere. If I take temperature, it is present everywhere. If I take the example of, say, pressure, it is present everywhere. If we take the example of elevation, everywhere there will be certain elevation. So such type of data is called continuous data. Okay. So these are two different types of data: raster data, vector data. It depends upon whether it is a continuous data or whether it is a discrete data. So if it is continuous, we will go for the raster data modeling. In raster data modeling, the whole space is divided into cell, into pixel. It is a gridded data. When we talk about the vector data, it is basically, it uses Cartesian coordinate system. It will have X and Y coordinates corresponding to everything. Like we can store the data in point, line, polygon in three different ways. Okay. I will continue with this raster vector and the example of these two models. But first, I'm giving you 10 minutes break. and we will start our class after 10 minutes.
Ma'am, one thing I have to ask, ma'am.
Sorry?
Ma'am, that what you explained about continuous and discrete one, how we are categorizing that in continuous time we are using raster and discrete time we are using vector.
No, you have to decide in the, you see this one. This one is about the entity definition. So when you are defining any entity, identification of discrete and continuous feature is needed. So when you are doing the modeling, you have to decide. And this thing is not fixed. Okay, depend upon the modeling method, whether you are going to, like, you can represent school or hospital in a continuous manner also. And you can use it in a discrete manner also. But it depends what is the application and how we are going to model it. So you have to see, you have to think what will be the best way of representing, whether the graded way of representing school is better or not. Obviously it is not. So we will go for a discrete representation. It depends upon the person who is creating all this, who is doing the spatial data modeling and who is building the GIS. It depends on him or her, that whether they are taking it like a discrete object or as a continuous object.
Okay, ma'am.
Let's start the class again. And we have left at raster and vector data analysis. So you have just seen about the raster data and vector data. Right now on the screen, you can see the example of raster and vector, how the data is getting stored inside the raster data and vector data. So in the Happy Valley example, the hotels will be represented by point. Okay. So these point, if stored in the raster form, they will be represented like this way. Okay. So this layer, the one layer will be based on one theme, particular theme. Okay. Like when you were doing the digitization in lab, you have seen that you have created different files. For tree, there will be one file. For the religious places, there will be another file. For, say, huts, there will be another file. So for every point feature, you have created a different file over there. Here also you can see in the raster also, suppose if you want to store hotels, so this complete grid, okay, this complete grid will be the hotel grid, and where the cell is in black color, okay, they are showing at these particular position the hotels are present. Where it is filled with white color, there is no hotel. The same information could be represented in the vector form like this. Okay, so instead of using the gridded form like raster data, in case of vector data, the coordinates are stored, the Cartesian coordinates are stored to represent these hotels. Second example is of skiing lift, or you can think it like a road. Okay, instead of ski lift, you can think that this one is representing a road. See how the road is represented in raster and how it is represented in vector. Again, same thing. There will be a grid of road, and wherever the road is present, it will be represented like this way. See the difference in the shape. Okay, when we are storing it in the vector form, just 3 coordinates are required, and they get the shape of the road will get saved. But in this one, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Approximately 14 cells are required to represent the road. The third example is of forest. This one is the polygon or area. In case of raster, this is how this polygon will be represented, and this is how in vector it will be represented. So before continuing with this raster and vector detail, we will see some more example. This one is the another example of raster representation and the equivalent vector representation. Okay, on the left hand side, you can see that this one is the raster data. The same region is represented in the vector area like this. I will show you the example in ArcGIS software also. I'm taking the example of California. Okay. Right now on the screen, I have opened the California. If there is any lag between audio and video, you can inform me about it. Right now, yes.
मैम अभी थोड़ी देर पहले जो आपने बताया स्पेशल एंटिटीज से रास्टर और वेक्टर रिप्रेजेंटेशन करते हैं, तो मैम उसमें ये कैसे डिसाइड करते हैं किसी स्पेशल एंटिटीज के लिए कि उसमें हमको रास्टर रिप्रेजेंटेशन में कितने सेल्स को फिल करना है और कहाँ फिल करना है?
इसके बारे में आएंगे कि रास्टर सेल कितना बड़ा लेना है। ये जब हम लोग रास्टर जब डिफाइन करते हैं, वो उसी समय डिसाइड होता है कि वो कितने साइज का हम ग्रिड लेंगे, कहाँ पर उसको रखेंगे। जैसे होटल है तो उसको हम कहाँ किस जगह पर उसको रखेंगे, वो तो उसका कोऑर्डिनेट से डिसाइड करते हैं कि उसका लोकेशन कहाँ है उस होटल का, उसके अकॉर्डिंग आप उसको मार्क करते हैं। इस पर अभी आ रहे हैं पहले से।
अच्छा,
हाँ,
ओके मैम।
नहीं पूछ लीजिए, उसको हम डिस्क्राइब कर देंगे।
जैसे मैम इसके पहले आपने जो एग्जांपल दिया था एक स्की वाला, उसमें काउंट करके आपने बताया कि 14 सेल यूज हुए हैं रास्टर इसमें रिप्रेजेंटेशन में। तो वही पूछ रहा था मैम कि वो कैसे डिसाइड किए हमने कि 14 सेल यूज किया, और स्की लिफ्ट में जो है कि 14 सेल यूज किया और कहाँ किस मतलब कैसे शेप में यूज किया, वो सब चीज।
इस टॉपिक पर अभी हम लोग आ रहे हैं, रास्टर डेटा मॉडलिंग। So before going to that one, first we will see the example of raster and vector. On the screen, you can see that there is a California state of United States. Okay. So in this California state, this representation is the raster representation. When I'm zooming in, you can see that this is converting into a pixelated, it is giving you a pixelated appearance of this whole area. Okay. So this is how the raster data is get represented. The next question was, as it was asked, that how we will know what will be the exact position. When you are placing your cursor over here on the bottom right corner, you can see that there are some values that are coming. Okay. This one is the X and Y coordinate of that location. So whether it is a raster data, whether it is a vector data, there will be a coordinate. You have already done the georeferencing of map. Okay. So when you are doing the georeferencing of the map is another example of raster data. So that one is in that case also, every pixel is associated with a location. Every cell is associated with a location. So this is how you will obtain the exact starting point and the end point of any road or any ski lift or any hotel or any forest. So the pixel has a location, and when you have to represent it on the raster form, based on that location, you will identify where we will going to put that forest or that road or ski lift. Okay. So in this example, you can see on the screen that when I am zooming in, the things are coming in a pixelated form. So this one is the example of raster data. Okay. So this one is the hillshade. You will learn about the hillshade analysis in theory as well as you will perform the practical of hillshade. When I'm clicking on any of these cell, the pixel value is coming. Okay. You can see over here, the pixel value is 155, object ID 77. Count is 1245. Count means number of pixel having the same value. Number of pixel having the value 155. So there are 1245 pixel. So there is only one attribute that is associated with any pixel. Whenever I am clicking, anywhere I am clicking, only a pixel value is coming. Okay. And if I try to open the attribute table, you can see this thing. So this is what the attribute table of raster data. The values are varying from 1 up to 242. Values varying from 76 up to 242, and the count number of pixel with that particular value is coming over here. Okay. So now,
So, ma'am,
when
what attribute
yes.
what attribute of the pixel will be used as primary key?
The pixel will be associated with just a single value, like in case of image. Okay, the pixel value will show the emittance value, the reflected value, the temperature maybe if it is of thermal band. So one pixel will give you just one single value in case of raster data. But when I will open the vector data. Like right now, I have clicked on California cities. So this one is the example of vector data. Okay. So this vector data will come in the form of point, line, or a polygon. Like California city is the example of point. If I click on the California outline, it is the example of polygon. So this is how the raster data is represented with every, like when I click on, when I'm clicking on the point, you can see the shape, the area name is coming. Okay. When I'm clicking on California outline shapefile, in this vector data, you can see area, state name, state FIPS, its region, its abbreviation. All this information is coming over here like this. So this is how the different appearance between the raster data and vector data. I will give you one more example. Okay. Right now on the screen, Right now on the screen, you can see the land use information. Land use information, again the same thing. With every, this one is the continuous data, okay, and this one is the example of raster data. See, when I am zooming in into this system, you can see everything is appearing like a pixelated form, isn't it? I'm zooming in and the things are coming in the pixelated form. And when I will check for the attribute table, when I am clicking on it, the pixel value is 6, the land use information is forest. Okay. So this is how the raster data is represented. It is represented in the pixelated form, in a continuous form. I will give you the example of vector data over here. Like these red color line are the built up area. These are basically the roads. Okay. And you can see how the roads are represented in the vector form like this. This is how the road is represented in the vector form, and see when I'm clicking on the raster form, this is how they are represented. The red color line are the built up area. These are for the road or any other built up area. See the difference in the representation of raster and vector over here. You need to observe the difference. Okay? You need to see how the things are getting depicted in different manner when they are represented in a raster form and when they are represented in a vector form. So this is how the raster and vector are represented. Coming to the theory part. So first we will learn about the raster data modeling, and after that we will learn about the vector data modeling. In raster data modeling, there is a term called tessellation. Okay. No, first thing, one more thing. When we talk about the raster data, okay, so here you can see the raster data can be of two types. It can be a gridded data or it can be the image data. When you have the image, you will have pixels. When you have a gridded data, then it will be the cell. Okay. So when we are talking about the gridded data, the whole space is divided into cell. Whenever we have to model a raster data, the whole region will be divided into cell, and this is called the tessellation. When we divide a space into a mutually exclusive cell, then this thing is called tessellation. Raster data modeling is based on tessellation. Why? Because whole region is divided into gridded form, into a cell form. Okay? The shape of the cell can be anything. It can be it can be square, it can be hexagonal, it can be triangular, or it can have any irregular shape. Okay? But theoretically, it can be of any type. But when we store the data on a computer, instead of using any other thing, we will go for a square cell. Although the whole area can be tessellated in a form of hexagonal cells, in a form of triangular cell, it can use any type of irregular shape. Okay? But when we talk about the raster data, most of the time it is square cells. So the raster spatial data model is one of a family of spatial data models described as tessellations. Partitioning of space into mutually exclusive cells that together make up the complete study space is called tessellation. With each cell, some value is associated to characterize that part of space. In the raster world, individual cells are used as the building block for creating the images of point, line, area, network, and surface entities. Typically, these cells are square and evenly spaced in X and Y directions. The phenomena or entity of interest attribute values associated with each cell location. Raster layers are best used to represent continuous spatial phenomena such as elevation, temperature, and pollution concentration. This is one of the example. Okay. As you can see on the screen, this one is this grid is the raster data. Okay. And within this grid, there are different values corresponding to each pixel or each cell. 3, 3, 2, 2, 1, 3, 2, and so on. And then further, there can be another table, like values can be 0 to 4, the count 8, 5, 3, 8, 11. The type can be fallow, barley, wheat, corn. Condition can be fair, poor. Farmer name can be like this. You can see this thing in the example of land use also. Each location is associated with certain value. Each cell will have a value, and corresponding to that value, there can be a count, there can be a land use with that one. Okay, so this is what given in this example also. So this is how the raster data attribute are built. So this one is the extended raster data model. Note how each grid cell value has additional information stored in the database management system tables. Okay. This one is the another example of raster data. In the background, there are contour lines. Okay, so do not see those contour lines. Just see how they are represented in the raster form. The whole region will be divided into a gridded form, and inside each cell, the elevation value is given, or whatever value it is. So in each cell, certain value is given. Okay. Next thing is the raster cell. Okay. So smallest unit in raster is cell. The whole region is divided into mutually exclusive cell. This is what the tessellation that we have just studied. When we have a gridded data, in that case, we use the term cell. But when we have the image, instead of using the cell, the correct term will be pixel. Okay. With the image, it will be a pixel. And if it is a gridded data, then the correct word will be a cell. So raster cells are sometimes referred to as a picture element of pixel, a term that has its origin in digital processing. The minimum linear dimension of the cell is expressed in terms of dot per inch or DPI in an image, or as actual ground measurement is shown as spatial resolution. Spatial resolution determines the precision of spatial representation by raster data. Obviously, the smaller the size of the cell, higher the resolution and better will be the precision. Now let's see this thing in this example in this figure. So when you have a raster data, the whole space is divided into grid. So this is called gridded data. Each of this box, this square is called the cell. With this cell, there will be a term called cell dimension. What is cell dimension? Since we are using square cells, the length of each of the side, each of the edge will be same. And this edge, this length of the side is called cell dimension. Apart from the cell dimension, there is another thing called coordinate. You know, when we talk about the raster data and when we say it is a coordinate, the cell is not a point, it is covering some area, isn't it? When we talk about the vector data, in that case, the coordinate means a single point because it uses a Cartesian coordinate system. But when we talk about the raster data, we have this type of gridded data. So one cell inside this grid, it will cover some small area. It will not be a point. So sometimes there is a confusion. What will be the location of the coordinate? In some of the places, it is assumed at the center of the cell. In some of the places, it is assumed at the lower left corner of the cell. So basically, this cell coordinate is nothing but the position of lower left corner. So raster sets
And
have
these
a cell
cells,
dimension. Sorry.
and these cells are array memory locations.
आपको ऑडियो क्लियर नहीं आ रहा है, फिर से रिपीट करें क्वेश्चन.
And these cells are array memory locations. Hello.
Array memory location means like in the system we used to store everything in a matrix form, isn't it? आप सिस्टम में अगर आप स्टोरेज के लिए मेमोरी स्टोरेज के लिए पूछ रहे हैं कि किस तरीके से
Yes,
मेमोरी
sir.
स्टोरेज होगा, सो जैसे
Yes.
आप मैट्रिक्स स्टोर करते हैं, है ना, आप जब कोडिंग करते हो तो उसमें आप मैट्रिक्स बनाते हो, जैसे मैटलैब में करते हो तो हर चीज मैट्रिक्स है, किसी भी प्रोग्रामिंग
Yes.
लैंग्वेज में आप अगर स्टोर करोगे सो आप उसको एक मैट्रिक्स के फॉर्म में, तो जैसे मैट्रिक्स स्टोर होता है उसी तरीके से इसमें भी स्टोरेज होता है. तो ये उससे मतलब आपका जो भी स्टोरेज का मेथड होगा कि वो कंटिन्यूअस एरे के फॉर्म में स्टोर कर रहा है कि कैसे कर रहा है, तो बेसिकली एक मैट्रिक्स है. और इस मैट्रिक्स का जो पूरा मैट्रिक्स है ये सेल्स में डिवाइडेड है. सेल का अपना एक डायमेंशन होता है, डायमेंशन डिफाइन किया जाता है. क्योंकि ये स्क्वायर होता है, जो सेल यूज होती है सिस्टम में कंप्यूटर में स्टोर करने के लिए, आपका रास्टर का ओवरऑल शेप स्क्वायर भी हो सकता है, रेक्टेंगुलर भी हो सकता है, बट हर एक सेल का शेप जो होगा वो स्क्वायर शेप होगा. स्क्वायर शेप होगा. इसमें दो टर्म्स आते हैं. फर्स्ट वन इज द सेल डायमेंशन. व्हाट इज सेल डायमेंशन? द लेंथ ऑफ द साइड. एक सेल के साइड का लेंथ जो होता है वो सेल डायमेंशन होता है. दूसरा एक चीज आ रहा है सेल कोऑर्डिनेट. तो जैसे आपको यहाँ बार बार बता रहे कि रास्टर की जब हम बात करते हैं तो रास्टर का एक सेल कोई पॉइंट नहीं होता, बल्कि वो कुछ एरिया कवर करेगा. लाइक सपोज अगर हम बोलते हैं कि सेल डायमेंशन से 10 मीटर का है, तो एक सेल कितना एरिया कवर करेगा? 10 क्रॉस 10, इट इज 10 स्क्वायर मीटर का एरिया कवर कर रहा है. तो यहाँ पर कोऑर्डिनेट क्या दिया जाता है? जो लोअर लेफ्ट कॉर्नर का कोऑर्डिनेट होता है वही पूरी की पूरी सेल का कोऑर्डिनेट मान लिया जाता है. So raster set data sets have a cell dimension defining the size of the cell. The cells are usually oriented parallel to x and y direction. Thus, if we know the cell dimension and the coordinates of every one cell, example the lower left corner, we may calculate the coordinate of any other cell location. Square raster cells have a characteristic cell dimension. This cell dimension is the edge length of each cell, and cell dimension is typically constant for a raster data layer. The cell dimension is important because it affects many properties of a raster dataset, including the coordinates, data volume. What will be the relationship between cell dimension and cell volume? Anyone? Cell volume means number of cells. So what will be the relationship between the cell dimension and cell volume? If you reduce the cell dimension by half, say, what will be the effect on number of cells?
The number of cell will increase now.
Yes, it will increase, definitely increase. But what will be the relationship, exact relationship?
Ma'am, 4 times.
Okay. And if you reduce it by, if you reduce the cell dimension by 4 times, then?
Ma'am, 16 times.
16 times.
So now can you, yes. So if you are reducing it by half, it will increase by 4 times. If you reduce it by 4, it will increase by 16 times. Can you get relation now?
N square.
Yes, it is increasing by the square. As you can see in this example, in the very first one, in the figure A, cell size is 100 meter and there are 4 cells. Now the cell size is reduced by 50. Okay. If you reduce the cell size by 50, then there will be 16 cells. Each cell is divided into 4 cells. Now, this is one of the mistake that is done by the student, that when I say if I increase or if I decrease the cell dimension by half, okay, or if you need to divide, like there is 100 meter, instead of 100 meter, if I'm taking 50 meter cell size, automatically there will be an increase in 4 times of the cells. Okay. Sometimes there is a confusion, and instead of saying 4 times, students say it will be double, 2 times. So make sure that there is a square relationship between them. If you reduce it by half, there is 2 square, 4 times increase. If you reduce it by 4 times, square of 4, it is 16. So there will be an increase of 16 times. See this figure A, B and C, you will automatically understand the relationship. For 100 meter, there are 4 cells. For 50 meter, there are 16 cells. For 25 meter, there are 64 cells. किसी को कोई कंफ्यूजन है इसमें? कैसे ये बढ़ रहा है? कैसे बोला जा रहा है कि स्क्वायर से इंक्रीज हो रहा है? अगर आपको पूछा जाए कि अगर आपको अपने डेटा सेट को रास्टर में रिप्रेजेंट करना है, आप फिगर ए के साथ जाना चाहेंगे कि फिगर सी के साथ जाना चाहेंगे? मतलब आप 100 मीटर सेल डायमेंशन लेना चाहेंगे कि 25 मीटर सेल डायमेंशन लेना चाहेंगे?
25 मीटर.
Ma'am, depend on application, but C preferable.
ओके, कौन सा प्रेफर होना चाहिए किस एप्लीकेशन में?
Ma'am, if we want a more spatial information of the geographic feature, then we prefer C. And if we want a broader analysis of the geographic phenomena, then we prefer A.
What will be the problem with 25 meter cell dimension? What will be the problem with 25 meter cell dimension and what will be the problem with 100 meter cell dimension?
Ma'am, 25 meter cell data storage, ma'am, data will be more storage.
Okay, and with 100 meter?
Ma'am, data will be less, but in detailed information will be not there. Broad analysis we can do on the first one.
Actually, there is always a trade-off. Okay, why there is a trade-off? Because if you try to increase the size of the cell, like if you use the 100 meter resolution, the number of cells will be less. There are just only 4 cells, and the same area, if there is a 25 meter resolution, the number of cells are 64. There is a trade-off between cell volume or number of cells and the cell dimension. If you try to reduce the cell dimension, the positional accuracy will be improved. Like suppose there is a tree at this top left corner. Okay, so maximum variation is within this 25 cross 25 square meter, 625 square kilometer. This one is the maximum variation. Now see this one. If you place a tree in this cell, 100 cross 100, okay, 100 cross 100, so there will be 10,000 square meter. So you can see that in this case, okay, in this case there will be a variation of, Okay, I will know. Of 10,000. In this case, there will be a variation of 625. Okay, so this is what the difference is over here. If you are taking 100 meter cell dimension and place a tree over here in this cell, there is a 10,000 square meter area, which is, it can be at anywhere. But if you are taking this one, there is only 625 square meter variation of the position. So positional accuracy is better in case of smaller cell dimension, but the problem is the data storage will be much higher in case of smaller cell dimension. There are 64 cells, there are 4 cells. So if you run for the positional accuracy, there will be a loss of storage. There will be more large volume data will get produced, and later on, like you, all of you complain about the system, that your system is getting hanged, there is a crash in the software and other things. So as you increase the size, automatically there will be a problem. So there is what, there is a trade off. आप दोनों चीज आपको नहीं मिलेगी, आपको एक चीज लेनी पड़ेगी, एक चीज लेंगे तो दूसरी चीज का नुकसान होगा. अगर पोजिशनल एक्यूरेसी लेनी है, 25 मीटर पे आपको पोजिशनल एक्यूरेसी मिलेगी, ज्यादा एक्यूरेट रिप्रेजेंटेशन होगा. लेकिन दिक्कत क्या है, साइज बढ़ जाएगा. आप साइज कम लेना चाहते हैं, आपका सिस्टम हैंग कर रहा है, प्रॉब्लम करने लग जा रहा है, आपका सॉफ्टवेयर नहीं, उतना आपका सिस्टम नहीं ले पा रहा है, तो आप जाएंगे लोअर रेजोल्यूशन 100 मीटर पे चले जा रहे हैं. 100 मीटर पे ठीक है, नंबर ऑफ सेल्स बढ़ गए, कम हो गई, लेकिन वही एरर जो होगा वो बढ़ जाएगा. ये एक ट्रेड ऑफ होता है रास्टर डेटा में, क्योंकि सेल जो डेटा साइज होता है वेक्टर से रास्टर के केस में ज्यादा होता है, और रास्टर डेटा का साइज ज्यादा होने के कारण ये सारी प्रॉब्लम्स आपको फेस करनी पड़ती हैं. बट ये एक हमेशा एक ट्रेड ऑफ होता है दोनों के बीच में कि आप इनमें से किसको लोगे. So the volume of the data required to cover a given area increases as the cell dimension gets smaller. The number of cell increases by the square of reduction in cell dimension. The cutting of the cell dimension in half causes a factor of 4 increase in the number of cells. Reducing the cell dimension by 4 causes a 16 times increase in the number of cells. So there is a trade-off between the cell size and cell and data volume. Smaller cells may be preferred because they provide greater spatial resolution, but their detail comes at the cost of larger data sets. The cell dimension also increases the spatial precision of the data set and hence positional accuracy. The cell coordinate is usually defined at a point in the center of the cell. The coordinate applies to the entire area covered by the cell. Positional accuracy is typically expected to be no better than approximately half of the cell dimension. I will show you the example of this one. Just wait. So what I am doing, I am opening the Landsat image and I am opening the Sentinel image. Okay. What is the resolution of Landsat image in the visible band? RGB, what is the resolution?
Ma'am,
30 meter.
30 meter.
Yes. So all of you remember this thing. The Landsat image has a 30-meter resolution, except in the thermal band. Okay. So now I will show you one of the portion. I have zoomed in. This one is the 30-meter resolution Landsat image of the Prayagraj, and you can see how the road is coming. See, there is a road and everything is blurred over here. What is the resolution? The resolution is 30 meter. Now what I will do, I will open another image and see the change. Can you see this change? Can you see how clear the roads are now? This one is at 10-meter resolution. Okay. And what is the satellite? It is Sentinel. So Sentinel satellite has a 10-meter resolution in the visible range in RGB and NIR, near infrared. So you can see this thing clearly on the screen. This road, how this road is coming at the 10-meter resolution, but when I am opening 30 meter, you can see the whole road is getting blurred. अंतर दिख रहा है सबको? ये सारी चीजें ऑब्जर्व करना सीखे. जैसे कहीं कभी कोई आपको इमेज दिखा करके पूछे कि इसका अप्रोक्सीमेटली रेजोल्यूशन कितना होगा, तो आप बताने की स्थिति में रहो कि ये अप्रोक्सीमेटली, वही एग्जैक्ट तो बिना देखे बता नहीं सकता, बट अप्रोक्सीमेटली आप लेवल ऑफ डिटेल देखिए कितना इस पर दिख रहा है आपको. रोड का स्ट्रक्चर देखिए, उसके कर्व्स देखिए, उसके टर्न्स देखिए. जो ये अर्बनाइज्ड रीजन है उसमें देखिए किस तरीके से लाइटली हल्का हल्का आपको घरों का जो ऊपर का बाउंड्री रूफ टॉप जो होता है वो इसमें दिख रहा है. 30 मीटर पे देखिए जो स्लाइट है, हल्का हल्का जो बाउंड्री आपको रूफ टॉप का 10 मीटर पे दिख रहा था, जब इस सेम इमेज पर हम 30 मीटर का लैंडस्लाइड डेटा ओवरले करा दे रहे हैं, आप देखिए आपको कुछ नहीं दिख रहा, पूरा एरिया ब्लर हो रहा है. ये देखिए इस पोर्शन को देखिए, इसमें क्लियर कट एक सर्कल बनता हुआ आपको दिख रहा है. दिख रहा है ये यहाँ पर एक सर्कल आपको दिख रहा है. कर्सर के अराउंड हम मूव कर रहे हैं, ये सर्कल आपको 10 मीटर रेजोल्यूशन पे बनता हुआ दिख रहा है. 30 मीटर पे देखिए अंतर समझ में आ रहा है. रेजोल्यूशन का अंतर क्या होता है? स्पेशल रेजोल्यूशन इमेज के केस में सेल डायमेंशन, जब हम लोग रास्टर डेटा की बात करते हैं, सो चाहे वो इमेज हो चाहे वो ग्रेडेड डेटा हो, सब रास्टर की ही कैटेगरी में आते हैं. जब हम लोग रास्टर लेते हैं तब हम लोग उसको जब हम ग्रेडेड डेटा लेते हैं तब हम उसको सेल बोलते हैं, जब हम इमेज लेते हैं तो उसको पिक्सल बोलते हैं. वहां पर सेल डायमेंशन आता है, यहाँ पर इमेज में स्पेशल रेजोल्यूशन आता है. रिमोट सेंसिंग में अगर आप ये चीज यूज करेंगे तो वहाँ हर जगह स्पेशल रेजोल्यूशन बोला जाएगा. इमेज GIS में जब हम बात करेंगे तो सेल डायमेंशन बोलने लग जाते हैं. तो यहाँ पर आई होप सबको ये ऑब्जर्व सर ने कर लिया होगा कि रेजोल्यूशन का ये 10 मीटर के रेजोल्यूशन पे आपको कैसे सारी चीजें दिख रही हैं, और सेम एरिया को अगर हम 30 मीटर रेजोल्यूशन पर लेकर के जाते हैं तो किस तरीके से पूरा ब्लर हो जाता है. जो डिटेल है वो कम हो जाएगा, बट ऑब्वियसली साइज में बहुत अंतर होता है. साइज में आपको बहुत ज्यादा अंतर मिलेगा. दोनों इसमें रॉ डेटा मेरे पास है कि नहीं. इसका साइज देखिए, साइज देख रहे हैं 1.64 GB. ये किसका है साइज? ये लैंडसैट इमेज 30 मीटर रेजोल्यूशन का डेटा है, उस पर एक सिंगल टाइल का जो डेटा डाउनलोड हुआ है उसका रेजोल्यूशन 1.64 GB का आ रहा है. वहीं अगर सेंटिनल का शायद इसमें मेरे पास नहीं होगा अभी, ये सेंटिनल डेटा है. यहाँ पर प्रीवियस एग्जाम्पल में जो लैंडस्लाइड था उसमें कंप्लीट इलाहाबाद 2 टाइल में कवर हो रहा था, लेकिन जब हम सेंटिनल लेते हैं तो सेंटिनल में 4 टाइल्स हमारी लगती हैं, और आप देख सकते हैं 7 करीब करीब 800 की है, 823 की है। ठीक है, तो ये जब पूरा डेटा बनता है तो उसका साइज जो होता है वो बढ़ जाता है। इस तरीके से दोनों का अब आप डिफरेंस समझ सकते हैं। रास्टर डेटा में किस तरीके से स्पेशल रेजोल्यूशन, सेल डायमेंशन का इम्पैक्ट पड़ता है ऑन द विजुअल इफेक्ट, देन साइज का कितना ज्यादा अंतर होता है। अभी आप वेक्टर डेटा का खोलेंगे तो बहुत छोटा सा साइज होगा। एक वेक्टर डेटा का साइज जो है, अगर प्रयागराज का कंप्लीट अगर हम लोग डेटा देखते हैं, प्रयागराज विलेजेस का ये कंप्लीट डेटा सेट है अलॉन्ग विद एट्रीब्यूट, 12.8 MB का कंप्लीट डेटा है। आप लोग को डिजिटाइज्ड विलेज डेटा इलाहाबाद का दिखाया गया था, उसका वेक्टर डेटा का साइज 12.8 MB है। उसी का हम लोग रास्टर डेटा देख रहे हैं, उसकी सैटेलाइट इमेज देख रहे हैं, उसका साइज आपने देखा GB में आ रहा है, वो भी एक सिंगल टाइल दिखा रहे थे। ठीक है, तो इससे समझिए कि रास्टर डेटा का साइज हमेशा ज्यादा होता है, वेक्टर डेटा का साइज बहुत छोटा होता है। नेक्स्ट थिंग, इनकोडिंग ऑफ रास्टर डेटा इन कंप्यूटर्स। किस तरीके से आप रास्टर डेटा को कंप्यूटर में सेव करते हैं। अभी क्वेश्चन भी यही उठा था कि सपोज देयर इज अ रोड, तो उस रोड को हम किस तरीके से कहाँ किस सेल में लेकर के जाएंगे और उसको कहाँ पर स्टार्ट करेंगे, कहाँ पर खत्म करेंगे, ये कैसे पता लगेगा। इसको पहले देखिए, यहाँ पर एक वाटर बॉडी को यहाँ पर शायद दिखाया गया है, लैंड। ओके, तो यहाँ पर एक लैंड दिखाई गई है, ये ग्रीन कलर से आप यहाँ देख रहे हो, दिस वन इज द एग्जांपल ऑफ लैंड ऑन अ रास्टर डेटा सेट। So first of all, what we need to do, we need to mark the position on the raster data. raster पे ये कहाँ पर लाई करेगा, ये पता कैसे लगेगा हमको कि ये कहाँ पर लाई करेगा, जो क्वेश्चन था कि स्टार्ट पॉइंट कहाँ है, एंड पॉइंट कहाँ है रोड का। ठीक है, या इस केस में पॉलीगन यूज हो रहा है, तो पॉलीगन में कौन कौन से सेल में वो लैंड है या वो फॉरेस्ट प्रेजेंट है। आप जब भी किसी चीज को लेते हैं तो उसका लोकेशन आपके पास में होना चाहिए, तभी तो रास्टर डेटा बन रहा है। रास्टर डेटा किसका बन रहा है, स्पेशल डेटा का बन रहा है ना। ये रास्टर डेटा कहाँ से निकल रहा है, डेटा स्पेशल डेटा, देन वी आर गोइंग टू द रास्टर डेटा। तो रास्टर डेटा जो क्या है वो स्पेशल डेटा से आ रहा है, उसका लोकेशन होगा तभी आप वो रास्टर बना रहे हैं। तो आप जब भी रास्टर डेटा क्रिएट करने जाते हैं उसके लिए सबसे पहले आपको उसका लोकेशनल डेटा लेना पड़ता है। वो लोकेशन डेटा कैसे आ रहा है वो डिपेंड करता है, लाइक वो सैटेलाइट इमेज के फॉर्म से भी आ सकता है, आप कुछ इमेज प्रोसेसिंग करके भी वो डेटा निकाल सकते हैं। लाइक लैंड सरफेस टेम्परेचर है, LST हमको निकालना है, हमको LULC निकालना है किसी जगह का। हमारे पास ये सैटेलाइट इमेज थी, यहाँ पर आप देखिए, यहाँ पर एक रास्टर डेटा जनरेट किया था स्टूडेंट ने, इनको अर्बन एरिया चाहिए था सैटेलाइट इमेज पर। ठीक है, अब वो अर्बन एरिया कहाँ से लेकर के आएंगे। अर्बन एरिया लाने का एक तरीका ये है कि इन्होंने ये सैटेलाइट इमेज ली थी और सैटेलाइट इमेज पर ले जा करके, आप फ्यूचर में आगे देखेंगे, आगे इमेज प्रोसेसिंग वगैरह सीखेंगे, तो यहाँ पर देखिए ये पूरा रास्टर डेटा इन्होंने अर्बन का जनरेट करा दिया। अब यहाँ पर स्क्रीन पर आपको क्या दिख रहा है, ये एक रास्टर डेटा के फॉर्म में ये अर्बन एरिया दिख रहा है। इसको हम जूम करेंगे तो आप देखेंगे पूरा का पूरा पिक्सेलेटेड फॉर्म में आपको ये दिख रहा है, ये रीजन। तो ये क्या है, ये एक रास्टर डेटा है जो यहाँ पर जनरेट हो रहा है। इस रास्टर डेटा को अगर हम इसका साइज अगर हम चेक करें, यहाँ पर देखिए raster information columns and rows 936 columns and 704 rows. So ये क्या मतलब है इसका कि ये पूरा का पूरा जो स्टडी एरिया है इस काम का, इसका जो एरिया है ये नंबर ऑफ कॉलम्स इसमें 936 है, नंबर ऑफ रोज 704 है। और उसके बाद वहां पर इस पूरे एरिया को अर्बन में दिखा दिया गया है। वापस से इस एग्जांपल में आते हैं। So entity model, it represents the whole raster data. Let us assume that the raster data belong to an area where land is surrounded by water. Here a particular entity, that is land, is shown by green color, and the area where land is not present is shown by white color. Okay. Then एक बार ये काम हो गया, अगला स्टेप क्या है? Pixel values. The pixel value for each cell is assigned. Cells having a part of the land are encoded as 1 and others where land is not present are encoded as 0. Okay. तो सेम चीज इसको कन्वर्ट करी गई। ये तो एक एंटिटी मॉडलिंग हुआ। जब आप सिस्टम में सेव करेंगे तो आपको इस तरीके से नहीं सेव करेंगे, आपको इसको इस तरीके से कन्वर्ट कराना पड़ेगा सबसे पहले पिक्सल वैल्यूज में। तो यहाँ पर आप देखिए, जहां पर लैंड नहीं है वहां पर 0 दिया गया और जहां पर लैंड प्रेजेंट है वहां पर 1 दिया गया। थर्ड, फाइल स्ट्रक्चर, जिसमें एक्चुअल फाइल स्ट्रक्चर में जब सेव होता है सिस्टम में, so it is the method of coding raster data. The first line is the file representing the dimension of the matrix and the number of entities present. In the second and subsequent line of the file indicates the presence or absence of the entity. ठीक है, इस तरीके से ये पूरे के पूरे रास्टर डेटा को मॉडल किया जाता है। कहाँ पर है कहाँ पर नहीं, सबसे पहले ये निकाला जाता है। यहाँ पर सिंगल एंटिटी के लिए दिखाया गया है, मोर देन वन एंटिटी का भी हो सकता है। ठीक है, सिंगल एंटिटी में एक और एग्जांपल देख लीजिए, इसको वही सेम है, एंटिटी मॉडल, देन सेल वैल्यूज, देन फाइल स्ट्रक्चर। ये एक सीक्वेंस होता है रास्टर डेटा का। जहां पर एंटिटी प्रेजेंट वहां पर 1, अदरवाइज जहां एब्सेंट वहां 0। यहाँ पर एक सिंगल एंटिटी को लेकर के किया जा रहा है, यहाँ पर मोर देन 1, यहाँ पर 3 डिफरेंट एंटिटीज हैं। सपोज यहाँ पर ग्रीन फॉरेस्ट, ब्लू वाटर एंड व्हाइट स्नो को दिखा रहा है। तो यहाँ पर 3 डिफरेंट कैटेगरीज है, स्नो, वाटर एंड फॉरेस्ट। और इसका इक्विवेलेंट सेल में यहाँ पर देखिए किस तरीके से 1, 2, 3 के फॉर्म में इसको लिखा जा रहा है। हर एक सेल के करस्पॉन्डिंग एक पिक्सल वैल्यू सेल वैल्यू दी जा रही है और फाइनली उसका फाइल स्ट्रक्चर बनाया जा रहा है। कैसे बन रहा है? नंबर ऑफ रोज, नंबर ऑफ कॉलम्स 10 क्रॉस 10 यहाँ पर है। ठीक है, देन नंबर ऑफ एंटिटीज, यहाँ पर 3 थी तो यहाँ पर 3 ले लिया गया, एंड देन रेगुलर यहाँ पर जो नंबरिंग करी जा रही है, जो यहाँ पर नंबरिंग है सेल वैल्यूज की, वही यहाँ पर आ जा रही है। अब क्लियर हो गया? जिसका भी क्वेश्चन था कि कैसे रास्टर में सेव होना है वो क्लियर हो गया है।
मैम 1, 2, 3 जो वैल्यूज है ये खुद से लेंगे हम
मींस सॉफ्टवेयर में जब हम प्रोसेसिंग करते हैं तो उसको हम असाइन करते हैं वहां पे। अगर आप इमेज ले रही हैं तो बाय डिफॉल्ट है वो, मतलब आपको वो वैल्यूज मिलती हैं। मींस सेंसर जो है वो जो भी आपका सेंस कर रहा है, सपोज टेम्परेचर सेंस कर रहा है तो उसकी वैल्यू, या रिफ्लेक्टेंस को सेंस कर रहा है तो उसकी वैल्यू, या एमिसिविटी को सेंस कर रहा है, जो भी सेंस कर रहा है उसकी वैल्यू सेंसर डाल करके उसमें आपको फाइनल आउटपुट में मिलता है। बट जब आप रास्टर डेटा खुद से जनरेट करते हैं तब उस केस में आप वैल्यूज बना सकते हैं। जैसे कि इमेज से लैंड यूज लैंड कवर का डेटा निकालना था, तो वहां पर हमें क्या वैल्यूज देनी थी वो हम डिसाइड करा सकते हैं कि हमें यहाँ पर क्या वैल्यूज देनी है।
ओके
तो यहाँ पर जैसे जहां अर्बन प्रेजेंट है वहां 1 दिखा रहा है, जहां अर्बन नहीं है वहां नो डेटा करके वैल्यू आ जा रही है। इस तरीके से ये मतलब डिपेंड करता है कि वो रास्टर जनरेट कैसे हो रहा है। अगर आप खुद से जनरेट कर रहे हो तो वो वैल्यूज यहाँ पर दी जा सकती हैं। यहाँ पर देखिए ये यहाँ पर ये सेम वही प्रयागराज का एरिया लिया गया है और यहाँ पर लैंड यूज लैंड कवर क्लासिफिकेशन स्टूडेंट ने परफॉर्म किया और यहाँ पर देखिए अलग अलग कैटेगरीज आपको यहाँ पर इंडेक्स वैल्यू देखिए अलग अलग आपको मिलेगी। ये अलग तरीके से जनरेट है, तो इस तरीके से ये डिपेंड करता है कि आप उसको जनरेट किस तरीके से करा रहे हैं, उसके बेसिस पर इसकी वैल्यूज यहाँ पर आती हैं। एनी अदर क्वेश्चन? नेक्स्ट इज डेटा कंप्रेशन। डेटा कंप्रेशन क्यों जरूरी है? क्योंकि अभी जस्ट आपको साइज दिखाई गई रास्टर डेटा की। So the size of the raster data is too large, and this one is a very common problem when we are dealing with the raster data set. Therefore, it is necessary to save the data. It is necessary to compress the raster data. That's why we need to learn about the different methods of raster data compression. There are 4 methods of compression: run length encoding, block encoding, chain encoding, and quad-tree data structure. These are 4 different types of data compression techniques. We will cover this data compression in the next lecture session. Okay. So on Friday, we will have a lecture from 11 o'clock. So we will cover this topic of data compression, raster data compression over there. So that's it from my side for today. On Friday, there will be a lecture, and after the lecture, there will be a quiz. As I have written down in on the Teams, that the syllabus of this GIS quiz will be from first note of introduction up to the 4th PDF file of other data sources. So this is about the syllabus of quiz. Okay. तो सभी को इंश्योर करना है कि वो क्विज में जरूर से प्रेजेंट हो, क्योंकि क्विज के जो मार्क्स होंगे वो डायरेक्टली मिड सेमेस्टर में, यानी कि आपका जो फाइनल 100 मार्क्स में आप इवैल्यूएट होते हो, उसमें डायरेक्टली क्विज के मार्क्स ऐड अप होते हैं। एज इट इज ऐड नहीं होंगे, क्योंकि आपकी कई क्विजेस होंगी, वो स्केल होते हैं, आउट ऑफ 20 पर उसको स्केल किया जाएगा, एंड फाइनली जो 20 मार्क्स का मिड सेमेस्टर का कंपोनेंट है, वो पूरे के पूरे 20 मार्क्स आपके क्विज से आएंगे। एक भी क्विज आप मिस करोगे तो ओवरऑल कंपोनेंट पर उसका काफी असर पड़ता है, इसलिए हमेशा मेक श्योर करें कि सभी स्टूडेंट क्विज के दिन, क्विज के समय पे प्रेजेंट रहें और अपना क्विज कंप्लीट करें। तो मेरे ओर से इतना ही। अगर आपके एंड से कोई क्वेश्चन है तो आप पूछ सकते हैं।
मैम हेलो।
यस
मैम कल असाइनमेंट अपलोड करा था मैम 12 बजे से पहले, पर मैम वो अभी भी हैंड इन लेट में शो हो रहा है मैम।
कोई दिक्कत नहीं, आपका अपलोड हो गया है ना?
ओके मैम।
अपलोड अगर हो रहा है कोई दिक्कत नहीं, अपलोड अगर नहीं हो रहा है तब आपका वो प्रॉब्लम है। हैंड इन लेट आ रहा है, कोई दिक्कत नहीं है।
मैम
यस
मैम लाइक आज मेरी पहली क्लास थी, तो क्या हमें भी असाइनमेंट सबमिट करना मैंडेटरी है क्या?